Good morning, everyone. Welcome to the Enterprise Keynotes. The Enterprise program at Mplify is where innovation and enterprise leadership converge to shape the future of enterprise networking. You're going to shortly hear from Dan Snyder from UPMC and Nabil Bitar from Bloomberg. These gentlemen are founding members of the Enterprise Leadership Council. But before you hear from them, I'm going to give you a quick update on the Enterprise Leadership Program because that's become a driving force in some of the key initiatives that are currently at play in Mplify. So Enterprise Leadership Council was formed 2 years ago. And in just 2 years, ELC is already driving projects across automation, standardization, as well as AI, and across Mplify, and they're having a measurable impact. And the high order bid for enterprise leaders is really to collaborate with the key stakeholders of service providers, as well as technology vendors, to ensure that all innovation happens essentially in step and in line with their business needs and their critical needs for supporting their core business. We have 15 gentlemen, top leaders from global multinationals that are part of this leadership council. They represent about 9 distinct enterprise verticals. And this is not a passive advisory. We have many leaders here that are devoting and really contributing to some of the key initiatives that we have underway. Now, in terms of automation, this is a major milestone. SIM service is a major milestone. It's the fastest Mplify-approved standard in its history, MEF included, of course. And it basically replaces archaic manual coordination of maintenance windows, circuit impairment, with real-time communication on exactly that, circuit impairment or maintenance windows. And the result is, of course, that fewer downtimes, faster action, and very reliable network. CSA, or Cybersecurity Alert, is also industry first in terms of cybersecurity collaboration. This API service defines a two-way communication between the service providers and the enterprises in order to alert each other of either cybersecurity threats or the mitigation steps. And it covers a wide-ranging use cases from identity management, next-gen firewall, DDoS, data security, and such. Of course, implementing this and availing this service as it's offered by the service providers will only increase the network and security posture of the enterprises, making it a very robust enterprise network. The MVP functionality of this is already available. Palo Alto Networks and Prodapt have been kind enough to be very involved in this body of work, and they will be demonstrating this functionality through this conference. At Mplify, ELC has also issued 2 calls of action. One was the SASE manifesto that we issued in July, and it essentially calls for service providers and technology vendors to get their products and solutions certified so that enterprises can select and deploy these products and solutions with confidence. The LSO manifesto was issued yesterday, and it calls on the broader service provider ecosystem to essentially implement the standardized Mplify Day 0 and Day 1 APIs. And that's really essential for the entire automated, and essentially to close the automation gap and for them to have an entire lifecycle fully automated. Together, of course, these two create a very resilient and robust and scalable network for the enterprises. And finally, the AIOps. It's very important for the enterprises to have a predictive and real-time and automated AIOps tooling. So ELC is defining must-have requirements that ensures that these tools have essentially actionable insights and real-time diagnostics and integrate seamlessly in their ITSM or their network systems. So in summary, these gentlemen realize that it's essential, very critical, to collaborate with the key stakeholders of the service providers and technology vendors in order to shape the future of enterprise networking to their business needs. So join the movement, get involved, support the ELC, and together let's help them do exactly that. Thank you. And now let me bring out Dan Snyder from UPMC. Welcome, Dan.
Thank you, Sunil. Thanks for having me. All right. So let's get started. So UPMC. UPMC is a healthcare payer provider, meaning they provide healthcare and provide insurance for healthcare. We're a global company. We have locations in Pennsylvania, New York, Maryland, also Ireland, Italy, Croatia, and some others. We have around 40 hospitals, about 800 outpatient facilities, 110,000 employees. We're the largest employer in the state of Pennsylvania. 4 million people have our health plan. We were also listed as one of the most wired hospitals for 2024. So what does our network look like? We have about 1,800 routers, 7,000 switches, 26,000 access points, and 400 firewalls. How's that stuff connected? We connect our network to the public cloud. We have 800 gig. It's 400 to one area in the United States and 400 to another area. We have 400 gig to the internet, 1.2 terabits between our primary data centers. We manage 40 compact data centers, meaning like inside the hospitals, there has to be local compute. And we have currently 3 dense wave rings that in the state of Pennsylvania that cover around 700 kilometers. What does the connectivity look like in one of these hospitals? Typically, we have 200 or 400 gig leaving the facility. All of the IDFs or telecom rooms are connected to the MDF at 2 by 100 gig that is active. We do multi-gig to our access layer clients. So we offer 1, 2.5, 5, and 10 gig. And wireless, we currently are AC and BE. We also offer sub-second failover, typically sub 50 milliseconds. Okay, so what is the challenge that we have with IoT devices? I guess first off, there's regulatory compliance, things like GDPR, HIPAA, NIST. We also have FGA and NFPA 99, the fire code. And this is typically checked in our facilities by either CMS, so Center for Medicaid and Medicare Services, or an organization from the government called the Joint Commission. And they're looking for that devices are known on your network and that you have them segmented appropriately. Okay, so I guess one other thing with UPMC. UPMC grows through acquisition. In the past 10 years, we've gone from 12 hospitals to over 40. And because of that, with acquisitions, typically there is minimal documentation. And so that creates a problem. If regulatory-wise, we're told, hey, you have to know what every device is, what's its functionality, and you have to segment it, that can be a problem. So let's see how big that problem could be. So this is one hospital that we have, Shadyside Hospital. It's in Pittsburgh. It's about 1 million square feet. It has, if you look at the ARP tables on the router, it has around 89,000 devices connected to those routers. Of that, 66,000 are directly managed by IT, and 23,000 are guest. And by guest device, I'll say it's not necessarily like a person visiting, but it could be an instrument or something that has to be in the facility but is not directly managed by UPMC's IT. So like, what are the device types? Guest internet, meaning in this slide, guest internet is like people visiting the hospital, bringing their laptop, their phone. They could be bringing a gaming system. If they're there for longer than a couple days, we let you bring an Xbox or a PlayStation. It could be IoT, it could be things like monitoring refrigerator temperature, it could be voice, like telephone systems for nurses, overhead paging, blue phones in parking garages for security. It could be building systems like HVAC, elevators, the clinical network, which is actually the medical devices, so like CT machines, and then the general network, which is just like PCs and printers. So what's available in the market to identify devices? Well, research-wise, there are dozens of papers on how to identify a device based on its request to DHCP, to maybe looking at machine learning with either the payload or other data that's being transmitted across the network. And that's typically found with like publicly available models. We also have standards, like the IETF has RFC 8520, which is MUD. MUD is Manufacturer Usage Description Specification, where pretty much the device tells the network what its use is and the communication that's required. And finally, we have vendor solutions, which are typically cost prohibitive and typically do not identify the devices properly. So I guess an example of like all of these, typically we'll say a device has a MAC address with an OUI that says, hey, it's vendor X. And so it's profiled either by the MAC address or by the payload that it's sending that, hey, it is vendor X's workstation. But in reality, even though there is like a Dell or HP server that's in front of a CT or PET machine, it's not able to identify it as a CT or PET. And that's like, we see this also with some vendors use Raspberry Pis. Yeah, well, you can identify it's a Raspberry Pi, but I don't know what the Raspberry Pi is actually doing. So how are we addressing the issue? Currently, we're still looking for a better way of doing this, but this is what we're doing now. So for us, we have an enterprise architecture review for everything new that's added. And to give you an idea, we have like, I'll say probably over 1,000 reviews a year of new devices that are being added to the network that are unique. Those reviews last 1 year. Part of the review, we interview the vendor that's providing the product, and we decide how we're going to segment that device. In addition to that, we have databases from Biomed and our CMDB that we try to register the devices in. We look at ARP tables, and we look at our network access control solution that we have to try to identify the devices. And we pull all this data together. We use Microsoft Power BI to keep track of what's been identified and if it's been segmented. But it's still more is needed. So like, what is needed? A better way to identify devices. And we feel that the regulatory requirements either need to be changed or updated to incentivize manufacturers to help. And this is just like one example of a challenge we face in healthcare. We face challenges in other areas. And participating in the ELC and Mplify has been beneficial to us because of things that Sunil mentioned, like SASE certification, the LSO APIs that enable automation. So that's it for IoT and healthcare. And I don't have time for questions, I'm sorry, but I will be here and I'll be around if you have any questions. Feel free to stop me. And now I will turn it over to Nabil Bitar from Bloomberg.
Hello, everyone. So what we're going to talk about is really the role of AI in operations, in particular in network operations, and how to build networks that we consider to be conscious. Let me see how I get, okay, I don't have the front slide showing up. Networks that are conscious, preventing guilt, and healing fast. And hopefully through that, we'll identify some opportunities that Mplify could play a role in that space. So to do that, first we'll talk about really traditional versus AI-based operations. We'll touch a bit on the capabilities leverage and operations for AI, some key use cases, and the building blocks for AIOps. And finally, we'll conclude with the current state, as I see it, at least the needs and what Mplify role could be in that space. Most of the enterprise environment are very complex. The applications are highly distributed, often connected across networks, connecting producers to consumers of that, including users. Underlying that are systems that come from different sources, including network elements or networks, as well as network-based solutions that come from different sources. So that creates really a burden on the operations team to be able to be fluent in managing these networks, to be able to operate them, jump on the CLI, command them to do certain things, extracting information, and so forth. So what happens when there is a problem often? And I have to confess, this is the only slide that's AI helped to be generated. I'm not such a good designer in here, but I prompted it right. So whenever a problem happens in such a complex environment, multiple operations and engineering teams jump into a virtual room. And in that room, they start looking at their own domain space, dashboards, tickets, logs, and so forth, trying to identify problems, sharing that finding virtual with their colleagues, and with the goal to really try to root cause the problem and remediate it. And during that, obviously, in such a complex environment, they run into stress conditions. They sometimes could pull their hair, but hopefully not each other's. And at the same time, they keep it civil, hopefully, right? So this operational environment as it exists today, what we call traditional operational environment, is pretty human intense, actually. And it's really burdened in multiple dimensions. Often there is a large alarm overload that happens, multiple alarms that could be actually triggering one each other, like the same failure could trigger multiple alarms. And that's really overloading the operations team going through these alarms. If you look at AIOps, it could actually look at correlating these alarms and consolidate them, so it reduces the burden on the operations teams. Often, these alerts are generated by static threshold sets on the metrics that are really sensitive to the seasonality, if we call it, like the time of the day, the day of the week of the month of the year, and so forth. And they are not sensitive to geolocation often, whether set at the application level or the network level. Whereas in AIOps, you could actually leverage dynamic thresholding based on baselining, auto-baselining. As we said earlier, in traditional operations, people sift through a lot of dashboards, keeping context as they flip through. And that's not an easy task for really human to do that, and keeping context across dashboards as they go across. Whereas AIOps enable the processing of data at scale, and in doing so, it helps really find the events that are collated in time and space, and helping the operations team to zoom into what could be the problem, if you will, so that they could focus on looking at that area. In trying to correlate events, what comes to use also is ontology as well as topology, how the application is connected, how the network is connected. That's really used by operations also to look at, is it based on tribal knowledge, based on documentation, whereas that for correlation, whereas that could be done automatically in AIOps. It tends to be often in traditional operation that we tend to be reactive. We wait to debug the problem when the problem happens. That's still the case in AIOps, that if a problem happens, you'll get the information hopefully faster or the insight to be able to root cause the problem and solve it, but also you could be predictive. Humans cannot be watching networks 24/7 around the year, basically, right? Whereas the systems are processing data that's being fed automatically, analyze them, and could detect deterioration or impairment that happen as a function of time, and as a result, you could alert of that deterioration and take action before it becomes a problem, and therefore it could be predictive in that way. And that's really what I mean by preventing guilt. So you don't end up being guilty as a network in causing an impairment to the application. The interaction often is syntax-driven between people and system in a complex environment with multiple vendors. People need to know every system CLI or API that they need to interact with. That's pretty good overload. Whereas leveraging AI and expert language models really that's specific to the networks, you could actually create natural language processing or use that to really interact with the system in a much easier way. And finally, the reasoning and correlation or root causing the problem is done by humans, where it's done by systems in the case of AIOps. And the remediation is purely human-driven today, whereas you could automate that. And the degree of automation could go from just suggestion to supervised remediation to fully automation. And that's really depending on the trust that you'll have in what AIOps is doing. Obviously, underlying that, there is a lot of data that needs to be analyzed. And to have good outcome, you need to have good data. And the data quality is still the burden of the engineering and operations need to provide. And that's, you cannot get away from that. That AIOps cannot help you with. So there are the techniques, really, not to go through one by one in this slide, but leveraging ML, machine learning, and LLM, large language models, and hopefully more specific language models to the network domain will help really address or kind of bring the advantage that I talked about in the earlier slide about the AIOps, from auto-baselining, or what we call seasonal anomaly detection, to really codifying human knowledge and sorting through that knowledge to suggest solutions to the problem. So this is really augmenting the human expertise that's operating the network and trying to home into what the problem could be, help remediating the problem, alleviating human mundane tasks and carrying the remediation. And at the end of the day, really the goal is to reduce main time to remediation. That's really the end of the goal. So there are many use cases that we look at, and this is not to mean a laundry list, but we've been talking about MTTI, or mean time to insight, mean time to remediation, through different techniques that are enabled by AI. The other advantage that we could get with AI is really leverage language models to model the knowledge, but also to be able to retrieve and generate information out of databases, knowledge databases that exist. To give you an idea what's involved and build on that a little bit, this is an eye chart, but actually what I tried to depict in here, what's involved really in building an AIOps system at very high conceptual level. You often have systems that could be network elements or enterprise system that are producing data. Data from network element could range from metrics, logs, meaning telemetry in general, but there could be also information pertaining to topology, ontology, ticket information that gets generated, as well as configs. And then there could be other systems, like you could have an external alerts that come from operators, for example, that there is maintenance. There could be change logs that had happened somewhere, that you take that and stream it through a data pipeline where that data gets enriched and streamed back to the insights platform where that insights is being done. And the insight could range in multiple flavors. It could range from detecting anomalies to correlating the anomalies to root causing, what the root cause could be, to really do predictive analysis. What could happen if that problem persists as a function of time? And data is presented usually to the people that are operating the network via a UI that could be based on natural language, meaning that you could interact with the system, or via GUI, or it could be taken up by network control applications to remediate the problem when the problem happens. And then you could have interaction with other agents and MCP servers to extract data from using tools that exist already on the network. So really, to onboard into the AIOps system, if you want to put it that way, on this environment, you have to really worry about the data, you have to worry about the interfaces, and the associated metadata that you're enriching with, and how that's going to be processed in the Insights platform. So what is the industry state and challenges that exist today from enterprise point of view in this? I look at it in three verticals. Really, there is the vendor space, the network equipment vendors or providers, that are, everyone almost is creating some solution in the AI space, but very specific to their equipment, all right? So that entails the use cases that they solve, the data that gets produced, and whatever they decide on to integrate with enterprise system. And there is good momentum in that space across the industry. But in a very multi-vendor, diverse operational environment, having silos across the vendor is not sufficient. So you have to create really horizontal solutions that take into account everything that exists on the operational environment. And that's really where AIOps solution providers or AIOps platforms can play, because they are multi-vendor. They come up with canned solutions, but more importantly, they allow the enterprise to onboard their own data into that platform and to define their use cases in addition to what comes out. Some of the issue right now in that space, that probably because of how much traction there is in the networking in this space, the solutions are not that abundant. And that's one of the problems that exists right now. On the enterprise side now, looking at how to adopt AIOps, there is actually a range. There are some people acting in that space and adopting AIOps in their operations, but that's not very widespread, I would say. So there is really the degree of awareness and education that needs to take place for people to know what AIOps could bring to them in value. Then, assuming that happens, that the enterprises are usually challenged with the data quality and onboarding that data into a selected solution platform or AIOps platform to help really produce the outcome that they desire out of that platform. Right? So in doing that, what usually runs, and what usually goes on is that you start in the AIOps adoption journey. In the first phase, you need to prove the use case. So you go through a couple of use cases. Once you do that, then you move to the next phase that you start defining use cases that are applied actually in operations. And you build on that later. You start really moving into supervised automation that I talked about a bit earlier, and hopefully aiming to more and more selective automation once you start gaining confidence in the outcomes and the decisions taken by the AIOps system. So with these challenges faced the enterprise, and the question becomes, what do we need to do? What's the industry need to be able to accelerate the AIOps adoption in enterprises? And that could be where the opportunity for Mplify to play a role in trying to accelerate that adoption. So one of them, as I said earlier, there is the awareness and education that has to take place. And people have to develop that by building business cases. We could accelerate that potentially if there are use cases that are proven, that have associated value that's seen. Then once you do that, then you have to worry about onboarding that data. So there are multiple interfaces that I showed in the prior diagram. If these are standardized, and at least the metadata is standardized, the structure of the runbook is standardized, the knowledge is standardized, then it eases the burden of onboarding data into the AI platforms. In particular, it could cut the upfront discussion really that often takes place. What is my data? How you process that data? What metadata you have? And all the stuff, and aligning that data. It could streamline that, and hopefully with time, you could have ready data that could be onboarded as a dream, maybe, on any AIOps platform. Then there is also, we often refer to large language models today. We know as the language models become more accurate, the more specific they are trained in a particular domain. So having network-focused language models will become very useful. And then obviously motivating the need to really ease the onboarding of people, onboarding of the system, to have NLP-based interaction with system is a good place to be. And we know there will be proliferation of MCP server, AI agent. As part of the education or the awareness, if there is a catalog of these things and the value that they could provide, that will offer really a good help, if you will, in terms of the enterprise space. So as a result of this, really what the ELC, the Enterprise Leadership Council, is working currently on a document that describes the needs requirements across the ecosystem that we see could help accelerate that, and hopefully that will be shared with the Mplify community in a short time to help really move in that space, or at least determine what can be done in that space. So I don't have time for questions, I know, but I'll be around. If people want to talk, I'll be more than glad to talk, and hopefully we could share ideas. And thank you very much.